All right, everyone, so this week we're going to focus on being able to simplify radical expressions. Today we're just going to start with some basic being able to simplify square roots, cube roots, and a couple other things. All right, so just some verbiage here that we should be familiar with. When you're looking at a radical, you see that the number up here is going to be called the index. All right, so like a square root, the index would be 2. A cube root, the index is 3. All right, and then so on and so on. Okay, we already know what a radical sign is. It's that thing that we've become familiar with. Kind of looks like a square root. Okay, and then the number on the inside, okay, the number underneath your radical is going to be called a radicand. All right, so let's take a look at a couple of examples with simplifying radicals. All right, so in order to simplify the radical, I pretty much break it into 2 steps. The first thing you want to do is break your radicand, your number underneath the radical, into 2 multiples, one of which is going to be your greatest perfect square. Okay, perfect squares being like 4, 9, 16, 25, and so on, 36, and so on. All right, and then you're going to go ahead and after you break it apart, okay, take your square roots, or whichever root it is, and then leave the other as the radicand. So if you can't take the square root of it, it stays underneath the radical. Okay, so looking at 45, we want to look at multiples of 45, one of which we want to be our greatest perfect square. Okay, so we'll break this into, say, 9 and 5, 9 times 5. Okay, 9 is our greatest perfect square that I'm talking about. Okay, and then 5 is just what we're multiplying it by. Okay, now what you can do is break it apart. Okay. So now I have the square root of 9 and the square root of 5. The square root of 9 we know is 3, and the square root of 5, we cannot take the square root of 5, so it stays underneath the radical, and that's going to be our simplified final answer. Okay, let's take a look at a couple more examples. Okay, we'll start with A, which is square root of 75. So we want to again break it into 2 multiples. One that's a perfect square, or our greatest perfect square, and one that is just our multiple. Okay, so 75 I can break into, say, the square root of 25 and the square root of 3. Okay, break it down. We got the square root of 25 times the square root of 3. The square root of 25 is our perfect square, so it's 5 square root of 3, and that's going to be our final answer for that one. Okay, now again, I say the greatest perfect square because if you were to use a number that was not the greatest perfect square, you'd have to simplify it further when you got to this final answer here. Okay, so that's kind of why we're using the greatest possible perfect square. All right, now I got the square root of 27. That one I can break into, let's say, 9 and 3. Okay, so then we got the square root of 9 times the square root of 3. Square root of 9 is going to be 3, and then the square root of 3 is not a perfect square, so that stays underneath the radical, and that's going to be your final answer for that one. Okay, and let's take a look at this one. Now in C we have 2 on the outside. That's just a multiple on the outside. That is not the radicand, which again is that number that would be underneath here. All right, so 2 is going to stay where it is, and we're going to multiply by whatever we get inside. Now 32, a lot of people would want to say 8 and 4. Okay, 4 is a perfect square, but it's not the greatest possible perfect square. So we want to use the biggest one we can think of, which is 16. So we can do 16 times 2. Okay, so it's 2 times the square root of 16 times the square root of 2 when we break it apart. Square root of 16 is 4, so it's going to be 2 times 4 times the square root of 2, because that's not a perfect square. That stays underneath the radical. All right, 2 times 4, 8 square root of 2, and that is my final answer because the number underneath the radical cannot be broken down any further. Notice when I get to the end here, 2, 3, 3, these numbers do not have a perfect square that you could break them into. All right, so that's all it is with simplifying radicals. These were all square roots today, but we'll go into some other ones as the week goes on, cube roots and some other higher roots. But that's pretty much the basis behind this stuff.